Okay, if you're building with LLMs right now, you really need to hear this. We are in the middle of a massive shift in thinking, a move away from just crafting clever little prompts and into a much more rigorous, disciplined practice, context engineering. This is about fundamentally re-architecting how we even communicate with AI.
Yeah, that's a pretty bold statement, right? But it cuts right to the chase of what we're talking about today. See, as we move from these simple, single-turn chatbots to truly autonomous agents, agents that have to perform complex, long-running tasks, the old ways are just breaking down. The art of wordsmithing is giving way to the science of systems architecture. It's a whole new ballgame.
So, here's our game plan. We're going to start with exactly why prompt engineering is hitting a wall. Then, we'll dive deep into the core technical limits, what we're calling the finite attention budget. From there, we'll explore this fascinating idea of the Agentic Goldilocks Zone. And then finally, we'll break down the real architectural solutions you can actually use to build more robust AI agents.
Right, so here's the absolute crux of it. We're not just asking an AI a question and getting an answer anymore. Not even close. We're building agents that have goals, agents that use tools that interact with file systems, that have to maintain a state over long periods. And in this new world, a static, handcrafted system prompt, it just doesn't cut it. It can't possibly adapt to the dynamic, messy, unpredictable nature of real-world tasks.
Now, I know what you might be thinking. Okay, but don't we just solve this with bigger and bigger context windows? 1 million tokens, 10 million tokens, problem solved. Well, that is a super common misconception. The hard truth is, larger context windows bring their own set of very serious problems, and it all stems from the fundamental way these models are built. We have to start treating context like a finite, incredibly precious resource.
Let's get technical for a second, because this is critical. It all comes down to the transformer architecture. The attention mechanism, the magic that makes LLMs work, it requires every single token in the context window to be compared with every other token. This creates a quadratic or n-squared relationship. So what does that actually mean? It means when you double the number of tokens, you don't double the work, you quadruple the computational load. This is what researchers call an attention budget. And trust me, it is not infinite. It has a very real cost in both performance and dollars.
And here is the essential trade-off laid bare. With a small, carefully curated context, the model's attention is laser-focused. The signal-to-noise ratio is high, and it can recall information pretty reliably. But as you just keep expanding that context window, you get what's called attention diffusion. The model's focus gets stretched way too thin. You run into context rot, and of course, the infamous lost in the middle problem, where the model literally forgets information that's buried deep in a long prompt.
This idea of context rot is so important. It's this wild paradox where adding more information can actually make the model dumber. You think you're helping by stuffing the context with every possible detail, but you're really just creating noise. The model starts to lose the plot, it forgets the original goal, it forgets key constraints, and its performance just nosedives. So this brings us to the central challenge for basically any AI developer today: finding what's being called the Agentic Goldilocks Zone. It's all about providing instructions that aren't too detailed, not too vague, but are just right for an autonomous agent to get a task done effectively.
And this is it. This is the key question every single one of us building agentic systems is grappling with. How do we give an agent enough guidance to keep it on the rails, but also enough flexibility to adapt and problem solve when it hits something we didn't expect? It is such a delicate balancing act.
Now, what I love about this is how it breaks down the two main ways we tend to fail. On one side, we have over-specification. This is where we try to script every possible move with this rigid if this then that logic in the prompt. It creates a system that is so brittle, it completely falls apart the second the real world deviates from its perfect script. Then you have the other extreme, under-specification. Just giving these vague instructions like, write a good report, and assuming the AI shares all our implicit context. And that, my friends, is a one-way ticket to hallucinations and completely irrelevant outputs.
So the answer isn't a more perfectly worded prompt. The real solution is to start thinking like an architect. We need to provide the agent with strong heuristics, with guiding principles, not a rigid set of rules. We have to empower its ability to reason, not just try to constrain it.
All right, so we've defined the problem pretty clearly. Now let's talk solutions. We're going to walk through 3 practical architectural patterns for managing an agent's state and memory, especially for those really long horizon tasks that span way beyond the single context window.
These are the 3 core techniques we're going to unpack. Context compaction, which is all about cleaning up the agent's working memory. structured note-taking, which is about giving it a persistent long-term memory, and sub-agent isolation, which is about dividing and conquering complex problems with specialized agents.
First up, compaction. So imagine a really long coding session. The agent has made dozens of tool calls, it's gone down a few dead ends. As it gets close to that context limit, you can actually have the model summarize the interaction. It preserves the critical stuff, like key architectural decisions or bugs it hasn't fixed yet, while throwing out all the noise from redundant outputs. Then, you just start a fresh session with that clean, high-signal summary.
Next, we have structured note-taking, or what some people are calling agentic memory. And this is just brilliant in its simplicity. You give the agent the ability to write to an external file, say a notes.md file. It can jot down its plans, log its progress, record key learnings, anything. This memory now exists completely outside the tiny context window, and it can be pulled back in just in time, only when it's actually needed. This keeps the working context lean, mean, and focused.
And this is not just for coding. Check out this incredible example of an agent that was tasked with playing Pokemon. Using a simple note-taking system, it was able to track its progress over thousands of game steps, build its own maps of regions it explored, and even learn combat strategies for different opponents. So whenever its context window would reset, it would just read its notes and pick up right where it left off. That enables a kind of complex, long-term planning that would be totally impossible otherwise.
And the third technique is sub-agent isolation. The idea here is, instead of one giant agent trying to do everything, you have a high-level orchestrator agent that delegates tasks to specialized sub-agents. Each of these sub-agents gets its own clean, isolated context window to do its one job, like, say, researching a specific topic. Then it just returns a condensed summary of its findings back to the main orchestrator. This keeps the lead agent's context clean and totally focused on the high-level strategy.
So as we start to wrap up here, it's pretty clear that context engineering isn't just another buzzword or technique. It is a fundamental mindset shift for anyone building with LLMs. It's about moving from being a propter to being an architect of the model's entire cognitive workspace.
This right here, this is the guiding principle. Your job is no longer to write the most eloquent, beautiful prose in your prompt. Your job is to be ruthless about curation. Every single token you allow into that context window must be a high-signal token that directly pushes the agent closer to its goal. And the crucial takeaway is that this is a dynamic process. It's not about setting one perfect system prompt at the very beginning and then just hoping for the best. No, it's about continuously, thoughtfully managing the information that flows in and out of the model's attention budget at every single step of a complex task.
And that really just leaves us with one final thought. You know, we're so used to thinking of code as the instructions we give to a computer. But for this new generation of AI, the context we provide, that is the code. It defines the agent's reality, its memory, its capabilities. So the real question for all of us is, how are you going to architect your agent's mind?